Let's now move on to the assembly design and virtually validate the motion of the new steering mechanism. Let's see what Eric was up to while Dan was busy on the board design. Eric has already created a steering truck mechanism that allows the board to lean, and the push rod assembly that controls how much power is being delivered to each track, which steers the shredder left and right. He'll be making changes to the design, so he starts by reserving the assembly since he doesn't want to step on anyone else's toes in the process. In a previous project, Eric used a tie rod assembly for a similar mechanism, so he does a quick search in the DTV's cloud library on the 3DEXPERIENCE platform. He can see that there are a few sizes to choose from, so he'll go with the 170mm tie rod for now. Next, he searches for a spherical hinge tie rod end. He needs one of those on each end, so once inserted, he'll make a quick copy. Assembling the tie rod to the steering truck is easy. Clicking two circular edges, the QuickMates toolbar intuitively filters to just the ones that make sense. By making the adjustment wheel transparent, you can now click the cylindrical face of the tie rod end stud and the inner face of the curved adjustment slot. The slot mate option will work well and will constrain the stud to only be able to move within the limits of the slot. For the next pair of mates, he knows that he'll need to access a few small internal faces of the rod end to mate it to the tie rod. By using Component Preview, he can rotate the rod end independently in its own window, while the rest of the assembly stays put in another window. The coincident and concentric mates are done in a snap, without having to move and rotate the assembly around searching for just the right faces or edges to click. Moving on to the lower rod end, he mates the stud to the push rod assembly, and then notices that the 170mm tie rod is just too short for the application. He changes the configuration on the fly, and then uses the Component Preview window again on the lower rod end to finish mating the tie rod assembly in place. Testing the mechanism, Eric can see that it's working well. Eric can see that the end comfortably hits the turning limits and are within the 1.25mm specification. All this without building and testing a single physical prototype. Finished with the steering mechanism, Eric saves his changes to the cloud. He unreserves the assembly and saves his changes up to the cloud. Data reuse by leveraging all the great data centralized in the cloud library, quickly mating everything into place, and virtually testing its function made this assembly task quick and easy. Eric's next task is to add comfort and control to the riding experience by tuning a bushing that will add the proper resistance when the rider leans the board.